Hello and welcome to the Kennedy Space Center in Florida for the pre-launch news conference for NASA's Earth-observing satellite called PACE. I'm Daryl Dale, and I'll be your moderator for today's news conference. PACE stands for Plankton, Aerosol, Cloud, Ocean Ecosystem, and its mission is to unfold the mysteries of our ocean and atmosphere. PACE will be launched by a SpaceX Falcon 9 rocket into a polar orbit from Space Launch Complex 40 on February 6th at 1:33 and 32 seconds a.m. Eastern Time. Joining me to answer your questions, the media in the room and on the phone, about the PACE launch and mission are to my left, Jim Free, NASA's newly minted Associate Administrator, Karen St. Germain, Director of NASA's Earth Science Division, Tim Dunn, Senior Launch Director of NASA's Launch Services Program, Julianna Scheiman, Director of SpaceX's Civil Satellite Missions, and Brian Cizek, the man on the hot seat, Launch Weather Officer for the 45th Weather Squadron of the U.S. Space Force. We're going to start with opening comments, and Jim, we'll have you get us started.
Thanks, Daryl. Good morning, and it's so exciting to be here for the launch of NASA's PACE mission to study what makes Earth different from every other planet, and that's life itself. Most of what we know about our changing planet is rooted in NASA's decades of Earth observations. And we currently have more than 24 satellites and instruments in orbit, creating a single great Earth observatory that provides layers of complementary information about land, ocean, ice, and atmosphere. And these satellites and instruments enable us to collect vital Earth science data, information we make available to people worldwide through our open data policy, which PACE will participate in after its commissioning. People can use this valuable data to make informed decisions how to safeguard our planet for generations to come. To answer some of the most pressing questions that we have about our environment, we've recently launched a number of new instruments in SWOT and TEMPO and EMIT. And PACE is the first of 2 additional launches this year, the other one being NISAR. We're also advancing our instrument and spacecraft technology to develop and fly the next generation of great Earth observers. Understanding how ocean life interacts with the atmosphere and the global climate is one of the secrets of the universe right here at home. Aerosols that cycle through the ocean and atmosphere are a factor in how clouds form and how weather systems behave. But exactly how that process works is a scientific mystery. Unraveling it is one big goal of the PACE mission, in line, of course, with NASA's charge to explore the unknown in air and space. This is incredibly important work and work worth doing, and it's important to both our nation and to the world. The knowledge we expect to gain through PACE during this mission about the complexity of the interplay of aerosols and clouds could guide policy decisions geared towards mitigating their effects, ultimately enhancing our ability to prepare for and respond to these events. I'm so proud, as always, of our NASA teams, in this case our team working the PACE mission, and the leadership of our Science Mission Directorate and Dr. Nikki Fox, Karen, and the entire team from NASA Goddard. I also want to highlight our Launch Services Program, which is responsible for the first steps of every one of our missions, and equally important. Amanda Mickiewicz, Tim Dunn, and James Wood and their entire team at LSP provide us invaluable engineering expertise in concert with the launch provider, in this case, SpaceX. I do want to wish Amanda well in her upcoming retirement, too. LSP is an incredible program on which we rely, and they deliver our missions to orbit. Today's launch, or tomorrow morning's launch, is not just a mission to space. It's a testament to our collective pursuit of knowledge, innovation, and the betterment of humanity for all Earthlings. So thank you very much, and go Falcon and go PACE.
Daryl? All right. Thank you, Jim. And you mentioned Karen St. Germain, so Karen, take it away.
Thank you. Well, it is a thrill to be approaching the PACE launch. You know, our Earth is a water planet. The surface of the Earth is covered 70% by oceans, and yet In many ways, we know more about the surface of the moon than we do about our own oceans. PACE will be the most advanced mission we've ever launched to study ocean biology. I like to say that PACE is a mission that will use that unique vantage point of space to study the smallest things that have the biggest impact. In the oceans, that's phytoplankton, these microalgae that are at the base of the marine food chain. They serve our fisheries and serve the health of the oceans, but they can also be toxic, and we need to know that too. They also are responsible through photosynthesis for absorbing a tremendous amount of carbon dioxide and converting that into oxygen in the atmosphere. We're also looking at tiny things in the atmosphere. These are called aerosols. They're tiny particles that play an enormous role in our weather, our air quality, and even our climate. They come from sources like dust blowing off the Sahara, wildfires, and even human activities. And they seed clouds that can grow into hurricanes coming across the Atlantic. But they also reflect a lot of the sun's energy. So they, too, play an important role in the long-term stability of Earth's climate. PACE, because we're measuring both of these things together, will allow us to also understand the strong interactions between the atmosphere and the ocean. PACE builds on 20 years of NASA ocean science and 60 years of NASA Earth observation. In the graphic that you'll see now, you'll see that PACE is joining, as Jim mentioned, a fleet of over 24 Earth-observing satellites that look at the oceans, the land, the atmosphere, and the ice to teach us about how the Earth works as a system and how that system is changing as it warms. It's particularly exciting to see how PACE will join SWOT. SWOT we launched a little over a year ago. That's giving us the most detailed view we've ever had of the physical oceanography, how water is moving in our oceans. And that is, of course, very closely related to what PACE will tell us about what's living in our oceans. It will also pave the way for some upcoming missions. The Earth System Observatory, the Glimmer mission. These are missions that are coming ahead that are going to stand on the shoulders of PACE. PACE is also just a beautiful example of our Earth Science to Action strategy. You know, the ocean economy makes up over $350 billion of our gross domestic product per year. It employs 3.1 million people in our country, but it also can experience adverse impacts from things like harmful algal blooms, which can cost $50 million a year or more. So the work we're doing with PACE and the work we do in Earth Science is about making observations that help us understand the Earth system, capturing that understanding in models and predictive tools, and putting that information into the hands of people who can use it to make better decisions every day. And with that, back to you, Daryl.
All right, very good, Karen. Thank you. And now let's move on to talking rockets. We'll have Tim Dunn, Senior Launch Director of NASA's Launch Services Program, continue with your comments.
Thank you, Daryl. I'm proud to be here today representing the women and men of NASA's Launch Services Program. I am the launch director for the PACE mission, and I'm thrilled to be a small part of this amazing team launching the PACE spacecraft. PACE is the 8th NASA LSP mission to launch on a SpaceX rocket and the first government mission to fly a polar trajectory from the Cape since November of 1960. Now, SpaceX is well seasoned in flying this particular trajectory. They've done it 11 times commercially since 2020, but this will be our first government flight in 60 years. PACE will depart Earth from Space Launch Complex 40 at Cape Canaveral Space Force Station. Slick 40 is near and dear to my heart. It was the location of my very first launch when I moved here to Brevard County over 30 years ago, launching a Titan IV mission, Millstar. So that brings back a lot of memories, and I'm looking forward to adding to that Complex 40 memory bank tonight. I would like to recognize the Falcon 9 PACE launch team, SpaceX, NASA headquarters, NASA Kennedy Space Center, NASA Goddard Space Flight Center, and of course, the United States Space Force's Space Launch Delta 45. This assembled group of professionals is absolutely world-class and is always a joy to collaborate with in executing a mission plan. I would like to pause for just a second, and I've said this before, but I feel the need to say it again. Launch is absolutely a team sport. It's composed of incredible individual high performers, but we don't do anything alone in this business. It's all about the team. And I wish I could invite you into some engineering review boards, into some of our flight readiness reviews or launch readiness reviews to see the collaboration that takes place to get us to this point. It's absolutely amazing. Now, speaking, though, of one of those individual high performers, Jim mentioned our program manager, Amanda Mickiewicz. She is retiring at the end of the month after a stellar NASA career, of which LSP has benefited tremendously from her leadership over the past 14 years. Amanda has been a caring and steady leader of our program, and we've done amazing things under her program management. So, Amanda, we will absolutely miss you. The entire Falcon 9 team has been busy with final launch preps. Last Thursday, the combined launch team held the flight readiness review, and then a day later, last Friday, we executed a successful mission dress rehearsal where we exercised the launch team in simulating the launch countdown and throwing in a few fun problems and anomalies along the way for the team to address. Then the spacecraft for PACE was transported. We had transported out to the pad, and we have now mated that to the Falcon 9 rocket yesterday, and I'm going to show you some video now. So let's roll that video. Okay, this shows the arrival of the PACE spacecraft a few months back in November, and we arrived at the Astrotech complex over in Titusville. That's our payload processing facility. Got incredible folks over there. That's a beautiful shot of PACE, and there's PACE mated to the top of the payload attach fitting, ready to be mated to the rocket. This is the payload fairing encapsulating PACE. Just great shots of the technicians working really hard and very carefully to take great care of our baby. Going to see some shots here of the rollout. This just occurred last Thursday evening where we rolled the spacecraft over from Astrotech, past the VAB, and out to Space Launch Complex 40 on Cape Canaveral Space Force Station. I've got some representative footage here from you from a few years back. This is Ixby rolling out of the hangar. So this did occur at 11 p.m. last night, and that is a live shot of PACE on the pad at Space Launch Complex 40. Beautiful Falcon 9 rocket there with our precious cargo mated to the top. So yesterday we held the joint NASA SpaceX launch readiness review. We call that the LRR. We received approval from senior NASA, Goddard Space Flight Center, SpaceX, and U.S. Space Force leadership to enter into countdown this evening. Yesterday at the launch pad, we began the process of final launch preps, as you saw, by rolling the Falcon 9 rocket with the mated PACE spacecraft out to the pad deck. Followed earlier this morning, about 4 a.m. Eastern Time, with erecting the rocket to its vertical position, as you saw at the end of the video. We do have some weather challenges to deal with today and tonight, as Brian, our launch weather officer, will cover for you soon. So weather permitting, late tonight at 10 p.m. Eastern Time, the launch team will arrive on console to perform final pressurization and vehicle checkouts. Early tomorrow at about 12:50 a.m. Eastern Time, the launch team will be polled for concurrence to load the Falcon 9 densified propellants. That's the chilled RP-1 kerosene and the liquid oxygen into the Stage 1 and Stage 2 propellant tanks. After completion of prop loading, along with a series of final launch vehicle checks and the transfer of the PACE vehicle power to internal, we will be ready for our targeted T0 of 1:33 and 32 seconds a.m. Eastern Time tomorrow morning. So to summarize, the Falcon 9 team and the PACE spacecraft are ready, and the launch team is prepared and excited to launch this vital ocean and atmospheric science mission. Back to you, Daryl.
All right, thank you, Tim. And NASA has entrusted SpaceX to put PACE into orbit. Let's have comments now from Julianna Scheiman.
Thank you. I'd like to start first by thanking NASA, NASA headquarters, Goddard Space Flight Center, and Kennedy Space Center for their support ahead of tomorrow's mission. It's an honor to be here today with all of you. SpaceX launched 96 times in 2023. And in 2024, PACE will be our 12th launch in just 35 days. And I will do the math for you. That adds up to about one launch every 3 days. And as Tim mentioned, a capability like that requires an amazing team. We have a team of engineers and technicians who are responsible for refurbishing our boosters, our fairings, and our Dragon capsules. We have a team of folks who are responsible for refurbishing our pad and ground systems and preparing them for the next launch. And we have a team of folks who are responsible for our spacecraft, encapsulating those spacecraft or preparing them by loading cargo or crew onto Dragon. A capability like this, a frequent, reliable access to space, directly supports NASA's mission. In January, we launched the Axiom 3 and Cygnus missions to the International Space Station. And coming up here in about a week, we have our Intuitive Machines launch, which will land on the South Pole of the Moon. Excuse me. But I'm here today to talk about PACE, which Tim mentioned is our 8th launch for the NASA Launch Services program. Everyone at SpaceX is exceedingly excited to support the PACE mission, which will help us understand the Earth, not just how the Earth works, but also how to care for it, which is especially important because right now Earth is the only planet we live on, so far at least. So with that, I would like to just thank NASA again for their support ahead of the mission, and over to Brian to help us fix those winds for tomorrow.
Indeed. Thank you, Julianna. And yes, I joked earlier that you're in the hot seat, Brian, but you're just doing your job. We understand you're staying with your 60% probability of violation, and we could see the clouds outside. Certainly something's going on weather-wise.
Yeah, that's correct, Daryl. And I guess it's my job to worry about the C in PACE for the launch tonight. And we are going to have some clouds to worry about and winds as well, as Daryl alluded to. But as we look at a live look at satellite, this is the GO satellite that, by the way, launched from right here a few years ago. And we do have quite a bit of cloud cover over Florida right now. You'll notice there's some spin in the Gulf of Mexico. That's all thanks to a pretty potent upper level low. And because of that, we do have a reflection at the surface with a surface low pressure. Now, during the day today, that will be slowly trekking across the state of Florida and will be in the Atlantic Ocean by tonight's launch window. But on the northwest side of that center of low pressure, which will be off to the east, we are going to see the pressure gradient tighten up right along the Florida east coastline. And that's going to cause an increase of winds. We're going to see this wind surge kind of come down the Florida coast from north to south. That's also going to bring some additional moisture into the area. So a few concerns with the launch tonight due to that. We are concerned about liftoff winds getting close to the limits. We're going to see winds increasing as the night progresses. Tomorrow we're going to see pretty high winds across the Florida coastline, and then they are going to start to decrease by tomorrow evening. So as we go to the launch forecast, we do have a 60% probability of violation, so that equates to a 40% go. Our main concerns being the cumulus cloud rule due to any showers that are along the coastline. So some of these rules, known as the lightning launch commit criteria, those are designed to protect not just against natural lightning, but against rocket-triggered lightning. A rocket can actually induce a lightning strike that would not have naturally occurred because it could increase the electric field in the atmosphere. So that's what that rule is designed to protect. We also have winds getting close to the liftoff wind constraints, so that will certainly be a watch item tonight as we see the winds increase from north to south along the Atlantic coast. And then also some lingering cloud cover, so that could be a concern for the thick cloud layers rule. So you add all those together, we're going with a 40% chance of go for the weather tonight. So then as we get to the primary day, the backup day, weather does improve a little bit, so we increase to 60% go. Really the main concern is again going to be the liftoff winds getting close to the constraint. A smaller chance for cumulus cloud with some lingering showers, but really I think for the backup day, the major concern will again be the liftoff winds. We said they kind of peak during the morning and early afternoon on Tuesday, and then when they do begin to decrease again as we head into Tuesday evening, and then the weather just continues to improve as we get beyond that. So the launch weather team, it's not just me. We have a team of launch weather officers and duty forecasters that will be on console tonight, ready to go, and we'll be ready to forecast and evaluate the weather the best we can. Daryl, back to you.
All right. Thank you very much, Brian, for explaining the weather system that is impacting our area right now. We will now take your questions, beginning with those here in the room at Kennedy. Please raise your hand, state your name and affiliation, and to whom you're asking your question. And we'll start in the room right now with Bill.
Okay, I'll ask a question. So, Bill Harwood, CBS. So, but if before fueling, is there any play in the window, or is it just an instantaneous window and you got to hit that on the second?
So we actually have just a little bit of play, Bill. We have it's a 90-second window that we have for pace. So that allows us to compensate for any COLAs, collision avoidance conjunctions that we may receive, but we don't have much to deal with a significant weather system that we want to delay an amount of time. So we're going to target the middle of that 90-second window. So we're really going to use the back 45 seconds of that to adjust for COLAs.
All right. Thank you very much. We have a question on the phone bridge now from Jonathan Siri with Fox News. Go ahead, Jonathan.
Thank you, Daryl. Thank you, everyone, for doing this. This question is probably for Jim Free. Tim Dunn had mentioned that this will be the first launch of a polar orbital NASA spacecraft aboard a commercial launch vehicle. What is the dollar value of NASA's contract with SpaceX for this? And if you could, talk about how this factors into NASA's long-term strategy of leveraging the private sector to increase space exploration. Thank you.
I'll let Tim handle the first part of that question, but I'll answer the second part. I mean, I think, I always point out we've done commercial launches for a long time, right? Our launch providers have been commercial companies. I think what we're leveraging here is, obviously it was mentioned that this is the 8th Falcon we've used for the launch services program. We're using a launch vehicle that fits the size of the mission that we have in this particular case, and we'll continue to leverage the flight rate that they have achieved with SpaceX and our other launch providers through the launch services program. That's how we get our validation of the capabilities and the engineering rigor that goes in to be ready for our launches. But the dollar value, I'll turn to Tim.
Wow. Thank you, Jim, for that opportunity. I mean, PACE is going to do incredible science, and with that, that's a lot of team, that's a lot of work over several years. So the total dollar value for to execute PACE, launch, build the satellite, execute the launch, and then operate the spacecraft is $948 million. And of that, I think your specific question was the launch vehicle portion of that cost, and that was approximately $81 million for the Falcon 9 service.
And Tim, talk a little bit about the Cape Polar launch.
Oh, yeah, I could talk at length about the history of Cape Polar and why we haven't done it as a government in 64 years. But I won't go into all that other than to say we did execute a handful of government launches back in the early 60s. And then on November 30th of 1960, that mission did not go so well as we were flying south and needed to obviously protect the public when the rocket does not do what we expect it to do. And unfortunately, debris did fall on our neighbors to the south in Cuba. And at that point, we as a government decided, let's just take all of our polar launch missions to the west. And we've successfully launched into the polar orbit hundreds of times since the 60s from Vandenberg Space Force Base in California. But along comes SpaceX a handful of years ago with autonomous flight safety system and the ability to either bring the first stage booster back to land here at the Cape or land it on a drone ship offshore. And by the combination of those two things, we were able to then do all of the calculations to protect the public both here in the U.S. as well as our international neighbors in the Caribbean and especially in Cuba, and to get the numbers right where we can now successfully do that. And as I mentioned, SpaceX, this will be their 12th launch into this specific polar orbit from the Cape. So there's no question about that this is a well-exercised process that we're doing. It's just interesting for the history of why we haven't done it in so long as a nation until a few years ago. So you can thank Julianna and her company for bringing us that capability.
Julianna, do you want to add anything, or?
No, Tim covered it. Thank you.
Okay, very good. All right, we have some questions on the line. We are taking live questions on hashtag #AskNASA. We've got the Maxinator 2002 and B who have questions in. We're going to get to those in a moment. But first, I want to take a question from Will Robinson Smith with Spaceflight Now. Go ahead, Will.
Hi. Thank you, Daryl, and thanks to everyone on the panel for taking our questions, and good luck with the mission. Julianna brought up the IM-1 mission coming up soon, so I just want to ask just a quick question about that, if I may. Can you bring us up to date on the processing for that launch, and what dates are you targeting for that mission? Thanks.
I can take that one if you like. Okay, thank you for the question. So our Intuitive Machines launch is targeting February 14th, Valentine's Day, for launch. And you asked a little bit about the processing, the series of milestones we have leading up to that launch. I think the most exciting milestone we have coming up is on February 7th, which is where we will perform a wet dress rehearsal, where we will load the spacecraft full of propellant. So one of the modifications we made to the pad to support the Intuitive Machines launch was to load methane and liquid oxygen onto the spacecraft prior to launch. We typically load RP-1 and LOX on the Falcon vehicle before liftoff, and we built in the systems at 39A to support loading methane and liquid oxygen. So we'll be performing essentially taking tests or a wet dress rehearsal for that spacecraft on February 7th, and we're tracking well to a February 14th launch.
All right, thank you very much, Julianna. And we have another question on the line. Stephen Clark is there. Go ahead, Stephen.
Hey, thanks, Daryl. I think a couple of related questions, probably for Tim Dunn. First of all, I know SpaceX is talking about certifying Falcon 9 boosters for perhaps up to 40 flights now. From LSP's perspective, what limit have you currently certified reflown boosters for LSP NASA missions? And also, is PACE utilizing a reused or previously flown payload fairing? And if so,
Okay. Question, I believe, for Tim.
All right. Yeah, I didn't hear the end of your question there, Stephen, but I got most of it there. So for the reused portion of, are we flying a reused fairing? No, we are not. We are under evaluation with SpaceX right now, and I would anticipate that to happen in the next year and a half or two. We'll see how that goes for the fairing. And as you saw the shot of PACE on the pad earlier, you saw the first stage booster did look a little bit of flight-proven worthiness stripes are on it. So this will be the fourth flight of this particular booster. And to answer your question about how many times we are comfortable with a reflight, Stephen, it's more, we don't look at the number of particular flights of a booster. We look at the qualification status of all the components that go into that booster. And so we do an evaluation, and as long as we do not exceed qual status, and some components do get replaced in between flights, and then we do the analysis on some of the structures that are not replaced, we are comfortable. So So far, I think we have flown, I know we've flown a 5th booster, and did we fly a 6th booster?
Europa Clipper will be a 6th.
Europa Clipper later this year will be a 6th flight currently. So you can see we're comfortable through analysis of components in that 4 to 6 reflight time frame today, and we continue to work alongside SpaceX to see if that number will go up in the future.
All right, thank you very much, Tim. And we want to circle back to a question in the room. Bill?
Hey, thanks for Jim Free. Can you talk about if the IM-1 flight goes off on the 14th, where does Crew 8 go? And if the fueling test doesn't go well on the 7th and you can't make the February window for IM, where would Crew 8 go in that case? Can you give us those two options, please?
Yeah, sure. So we're obviously following closely what's happening with IM for a lot of reasons, right? That's our CLIPS, one of our CLIPS missions, so it's important to us for the science we're going to get there. Right now, we're the 22nd is what the team is working to. If we have to watch what happens there, it could push out later to the end of the month. Crew 8, I mean. To later in the month, but right now we're working towards the 22nd with the possibility of going later depending what happens with IM.
And just a real quick follow-up for Julianna. Can you give us the launch window for IM in March? And how many days do you have in February to get off?
There are 3 opportunities, the 14th, the 15th, and the 16th, and I actually do not know the liftoff time, so I'll have to follow up with you offline with that. Oh, in March. I don't know the answer to that question.
All right, very good. Now it's time for some hashtag Ask NASA questions, so buckle up, everyone. Here they come. We're going to start with a question from Maxinator 2002, and he asks, why isn't this Earth science mission launching from Vandenberg, California? Because that is where most polar orbiting satellites launch. This is a very informed question, observing that we do most of our science missions out there. So, Tim, why don't you take that?
Right. I'll start this one, and then I'm going to turn this over to Julianna. But the way that the Launch Services Program contract with all of our launch providers is constructed is that all of the providers will bid on the opportunity to launch any of our spacecraft. And as part of that, we give the freedom to each of the providers to tell us what the best solution is for that particular spacecraft. So historically, this would have launched out of Vandenberg into a typical polar trajectory off of the central coast there. But SpaceX chose to bid the opportunity to fly here from the East Coast because they have the capability now. So, Julianna, you want to take it from there?
Yeah, sure. We wanted to optimize for Tim's commute. One of the things, when we're proposing a mission, one of the things we like to look at is to make sure we account for what the spacecraft team prefers. And in this case, the spacecraft team being from Goddard, they preferred to launch closer to their center. So Florida is much closer to Goddard than California. So here we are.
All right. Thank you both very much. Next question from hashtag Ask NASA comes from B, watching on YouTube. Would like an explanation of the blob images on the backdrop behind you. So if we go to a wide shot of our lovely graphic that we have behind our panelists, you'll see that lovely shot there. And I'm assuming the blobs are to our stage left at the far end. So Karen, direct your attention to that. Do you know what B is referring to?
I do. In fact, this is an image taken from our Landsat satellite. That's a partner mission with USGS, and it is intended to, in a very small way, represent what we will see from PACE. This image is actually off the coast of Brisbane, and you're seeing a number of features there. Off to the left, you'll see coral reefs. Over land, you can see smoke from wildfires. We can see some algae growing near the land. We can see some clouds. And even algae in the inland waters. So this is indicative of all the kinds of things we'll see from PACE, but PACE will give us another dimension to this, the beautiful imagery we have behind us. And I appreciate the question because it gives me a chance to say something. When we're talking about science, we don't always say this, but the imagery that we get from our satellites shows us in a new way how beautiful our home planet is and what a gem it is in the universe. So yeah, that's what this is.
Excellent. Karen with a sharp eye for the Landsat image, identifying that. That's well done. All right, moving on with more hashtag Ask NASA questions. We have Carol Kravitz asking, will PACE help with the analysis of heavy metals like mercury in fish populations? Karen.
It's a great question, and I don't know that we'll be able to measure mercury directly, but what we will be able to do is measure attributes of the community of phytoplankton that the fish eat. So we will be able to see changes in the fish food, and that will tell us an awful lot about fish health.
All right, very good. Another question. Chris Isles asks, will PACE help identify which nations contribute most to ocean acidification, and more importantly, how do they do that?
Well, so PACE is a global mission. We'll see all of the Earth's oceans, and through the ocean color measurements, we'll see what's growing where. Now, there are a lot of reasons that phytoplankton grow or don't. They need three things. They need sunlight, they need carbon dioxide in the atmosphere, and they need nutrients from land. They need nutrients to grow that they extract from the water around them. So how do the nutrients get there? One way is that the nutrients get transported from land via rivers and things like that. Another way is upwelling nutrients from the deep oceans. And a third way is actually from aerosols. All of these are global processes, but they play out differently locally, regionally around the world. So we'll learn a lot about the differences that we see around the coastlines and the deep oceans around the world. Yeah.
And you touched on this in your earlier comments, but the interplay between PACE and SWOT. PACE looking at the biology, SWOT looking at the movement of the ocean. Is there any impact that would help us shed light on the question, the acidification of the oceans?
Yeah, so generally the acidification of the oceans occurs through precipitation from the atmosphere, right? That's really the source in many cases. So with PACE, being able to observe the aerosols in the atmosphere and tell us about the biology, and SWOT telling us how water is moving around the planet, both that upwelling of deep ocean water, but also the movement of surface water. Yeah, these two systems together will really shed new insight into the ocean's health and how that's changing.
All right. All the questions are pointing to science at this point, Karen, so we appreciate you, fielding all of these.
We talk all day about it.
Oh, excellent. Very good. Well, we only have about 20 more minutes, but we'll certainly use what we have. High Q asks, NASA has studied Earth's atmosphere in the past. What is it you hope to learn that you don't already know?
That's a great question, and I'm going to pivot away from the ocean observing part of PACE for a moment and talk about the two other instruments on the satellite that really characterize aerosols in the atmosphere. These aerosols play a really important role both in short-term weather. They seed clouds, which can grow into storms and hurricanes. They also play a role in climate and the stability of climate. Aerosols reflect the sun's light, and they determine exactly what the composition of the aerosols is, how big they are, what their shape is, and where they are in the atmosphere will determine what kind of clouds they seed. That relationship between aerosols and clouds and its relationship to near-term weather and long-term climate is the greatest source of uncertainty we have, in particular in climate modeling. So this new insight from PACE will help us address the role of aerosols, how they create clouds, and how that plays out in terms of the forcing in climate feedback. Really important stuff. And then, of course, there's a relationship between the phytoplankton and the aerosols. We need, I mentioned nutrients that we need for phytoplankton. Often that can come from aerosols. We had a case with the wildfires. Remember the wildfires in Australia? That was a case where tremendous amount of burning led to carbon dioxide, but also aerosols, smoke in the atmosphere. That smoke carried nutrients out into a part of the ocean that normally doesn't have them. That drove an algae bloom, which then actually took carbon dioxide out of the atmosphere. So this interplay between the atmosphere and the oceans is critically important for us to understand how the whole system's changing.
And I'm glad you mentioned the wildfires in Australia. We have great imagery of that showing how that worked, and you can see that on tonight's launch broadcast. So shameless plug for the launch broadcast. Tune in, 12:45 p.m. In fact, I think I'm just hearing from our producer that we have that imagery. So we're taking it right now. And Karen, talk us through, as you look to Australia to the far left, you'll see it start to flare up.
Right. So what you're looking at here is actually the output of a model that takes all of the data we do have today and fills in the gaps with a physically driven model. So what you're seeing here are different kinds of aerosols. The colors on the bottom represent different kinds of aerosols. The intensity is how much. When we have a wildfire burning, such as you see in this loop in Australia, you'll see the orange aerosols, the carbon aerosols light up. Those also carry these other nutrients like iron and so forth that then get carried out over the oceans. I love this graphic because it shows how connected the Earth is as a system. But as I said, this is a model. What PACE is going to do is give us this kind of imagery, except from data. So it'll fill in all the gaps we currently have.
All the way around the world, too.
All the way
that
around
plume.
the world, yep.
Impressive. Thank you, Karen, for speaking to that on the spot. Appreciate that. Another question now. Moving from science to the spacecraft, MLG Pure asks, what is PACE's expected lifespan?
Oh, yep, I can answer that one. So the design life for PACE is 3 years. That said, usually our satellites live a lot longer than their design life, and that's why we're carrying 10 years worth of what we refer to as consumables. That's the fuel we use on board for station keeping, and when it reaches the end of life, to make sure that the disposal is safe. So we expect PACE to be on orbit for, we hope, 10 years, maybe even more.
Scientists are always hoping for more.
We are optimists.
All right, very good. We have a question now coming in on the phone line. Richard Trudeau from the Orlando Sentinel. Go ahead with your question.
Hi, yes, thank you for taking my question. This is for Karen. How much of this satellite data will help feed hurricane-related mitigation efforts? And what is the, if it's considered part of the arsenal of hurricane-related satellites that NASA is running up? That's it. Thank you.
Absolutely. That's a great question. One of the things I briefly mentioned at the beginning is that dust blowing off the Sahara is a big catalyst for the storms that develop over the Atlantic. And when the conditions are right, those storms can gather and strengthen and become tropical storms and hurricanes. So we expect the data coming from PACE to be a very important improvement in our understanding of how that process happens, and improving the predictive models that predict hurricane intensification and track. So I should mention here, Most of what we do through partnerships, and NOAA is a principal partner in this mission. They are an early adopter for many reasons, ranging from weather prediction to long-range climate to the harmful algal blooms and the things that affect fisheries. So yes, absolutely, this will be an important new piece of information that will support hurricane prediction.
All right, staying on the phones now, another question from Will Robinson Smith. Go ahead, Will.
Yeah, thanks for taking another question. This one also going to Karen, and then a quick one for Brian, if I may. I know the data from PACE will be made available to the public sort of continuously, but does NASA have plans for an annual report system from PACE, and what might that format look like? And then question for Brian, in the launch weather forecast for overnight tonight, is there any probability of hail in the forecast from a launch weather perspective? Thanks.
All right, I'll start with PACE. Yeah, absolutely. PACE is one of our, all NASA missions, all NASA Earth science missions and science missions in general abide by open source science principles. And here's what that means. That means we not only make all of the data freely and openly available, but we put the data, the algorithms, the models, we put all of that information out in real time. That does a couple of things. One, it accelerates the rate of scientific discovery if we have more eyes on the data and the tools in the hands of the science community. But it also accelerates the use of the information from missions like PACE by agencies and communities that can really make use of that information. In terms of a report, we have not historically focused on annual reports so much as continuous release of data and information. We have, if you go to earth.gov, you can see all of our Earth science data and learn more about the stories that we can tell with that data. And starting about 60 days after launch, you'll start to see PACE data showing up there as well.
And you can learn a lot more of that tonight when you watch the launch broadcast. I mistakenly said 12:45 p.m. I want to correct that. It's 12:45 a.m. as we all know. We'll be setting our clocks to come in early tonight.
And
all right. Brian, yes, I want to get the weather part of the question.
So I mentioned that upper level low during my part of the briefing there, and essentially part of that is it's very, very cold in the upper levels of the atmosphere. So that's part of the reason why we saw some hail reports yesterday. Today it doesn't look quite as favorable to get hail as yesterday. We don't have the amount of instability that we saw yesterday, so that's a necessary ingredient to get hail. Having that said, because it's so cold in the upper parts of the atmosphere, there is a small risk for small hail today, but lower compared to yesterday. I think it'd be more so earlier in the day today compared to the launch window, but it is a small risk given how cold it is in the upper levels of the atmosphere.
All right, thank you, Brian. Another question from #AskNASA. Con Savvy on YouTube asks, what are some of the awesome tools, the instruments on PACE? She believes they're awesome, and they are.
Well, we have three principal instruments on PACE. One is the ocean color instrument. That's the one that will produce the imagery like what you see behind me. And then we have two instruments called polarimeters. These are the ones that are measuring all those attributes, the shape, the size, the makeup of the aerosols in the atmosphere. So those are the instruments we have on board.
All right, and another one from #AskNASA. On YouTube, Freya Wild will ask, will PACE tell us about the oxygen created by phytoplankton? I'm guessing yes.
Yeah, it's a great question. So just like plants on land, phytoplankton grow using photosynthesis and oxygen and nutrients. And a byproduct of that process, just like plants on land, is oxygen. So knowing more about the abundance of phytoplankton, there are 20,000 species or so, and a billion phytoplankton in our oceans. So learning more about the abundance, where they are, what kind they are, will certainly tell us about what they are consuming and what they are producing. And in this case, what they produce is very helpful to us. It's the air we breathe. It's the oxygen in the air we breathe.
Indeed. All right. Well, great job, everyone. Thank you to all of our panelists for answering the questions. Special thanks to Karen St. Germain for answering a ton of questions today. Very good job with the science. We really appreciate it. Yeah. So if you'd like to learn more about PACE, just go to our website at nasa.gov/PACE. Again, nasa.gov/PACE. You can learn a lot more about the mission that is happening once that satellite gets up into space and commissioned. And as I've reminded a few times, the launch is at 1:33 and 32 seconds a.m. Eastern Time tonight, and our coverage for NASA television begins overnight at 12:45 a.m. Eastern Time. Thanks again to all of our panelists, and for all of us, for all of you joining us in the room and on the line and at #AskNASA. I'm Daryl Nail. Thank you, and go PACE.